Hello everyone, I am Rahul sir, your management educator. A warm welcome to Global Online Platform. Today we are going to discuss the correlation regression, which is most important topic of Unit 8, Statistics and Operation. Before this lecture, we have already discussed two lectures on Statistics and Operation Management. Here we are going, that is central tendency and dispersion. Now we are starting with the correlation and regression. Before starting, there is an important information for you that the UGC NET exam is very close. Anytime the date sheet can be announced from by NTA side. So this is the best time to boost up your preparation. We are offering the UGC NET Management Paper 2 course. If you take this course, you will get complete video lectures, full syllabus notes, test series and PYQ PDF with explanation. This is going to be a target-based preparation. The biggest advantage of this course is if you take the paper 2 course, paper 1 will be totally free. Okay. So here is all the contents which we have provided for your convenience in a well-structured and comprehensive way. What you have to do, you just have to download this, our official app, Global Online app. After downloading and login, you will see this home interface. In this home interface, you have to just click the store button. After scrolling, you can get the UGC NET Paper 2 Management course. Or you have another option that you can search it in the search box. After making the payment, you can access the content as many as times you want. To join the batch, contact on the given number through WhatsApp only. If you have any query after resolving query, after contacting, your query will be resolved. You have to just contact this number through WhatsApp. So we have done dispersion. Now we are starting with the correlation and regression. Okay. So what is correlation? Let's understand. Correlation simply means that there should be an study of an association between a variable, where either how much the variables are interrelated. It is mainly study in correlation. Okay, then correlation is a statistical measure that expresses the extent to which the two variables are linearly related, measuring their change together at a constant rate. Because what it is called, that it checks that whether any sort of relation exists between the two variable or not, whether this relation should be in a linear way. Okay, it's a common tool for describing the simple relationships without making statement about the cause and effect. Regression deals with the cause and effect, but correlation just checks that whether any sort of relationship exists between the two variables. Okay, it can be the variables can be two or more. We will study this in the types of correlation. Now let's see what are the different uses of correlation. So first one is, it is used in driving precisely the degree and direction of the relationship between the variables like price and demand. In economics, whenever we study the law of demand, we see that whenever the price will decrease, the demand will be greater and vice versa. Okay, then advertising expenditure and sales and rainfalls and crop yield, etc. These are the examples of correlation. Okay, then it is used in developing the concept of regression. Before studying the regression concept, it is necessary to understand the correlation. So whenever there is a correlation among the variables, then only we can say that there is a chance of cause and effect relationship. That is regression. The ratio of variations which help to estimate the values of one variable for the another, the given value of the another variable. So this is written about the regression. Then third is, it is used in reducing the range of uncertainty in the matter of prediction. Correlation helps in reducing the range of uncertainty. Okay, then it is used in presenting the average relationship between the two variables through single value or coefficient of correlation. The coefficient of correlation is generally used to present the average relationship between any two variables. Okay, then last point is there, in field of economics, it's used understanding the economic behavior and locating the important variables on which others depend. There are in economics, there is important to understand the consumer behavior to find certain factors. By understanding the relation between different variables which impact the behavior in of a customer's behavior in economics, in terms of economics. So it is very much important that there should be a correlation existing among them. Now let's see what are the types of correlation. What are the types of correlation we are studying? That correlation basically here is the chart which is classifying in 3 categories on the basis of degree of correlation. What's the degree of correlation? Here PN exists means positive and negative correlation. On the basis of number of variables, on the basis of number of variables, there is 3 type of correlation. SPM means simple, partial and multiple correlation. And on the linearity, on the basis of linearity, there exists only LN correlation. This is not that LN institution, it is L and N only. Then that which is means what? Linear and non-linear. So this classification is these types are important because it can be asked in match the column type questions. Okay, let's understand one by one. First one is positive correlation. When the variables are moving in the same direction, it's positive correlation. When the variables are moving in the same direction, it will be termed as positive correlation. Then we have negative correlation. When the variables are moving among the opposite direction in a negative is negative correlation. Then when the simple correlation, these two were according to direction. This earlier, this first and second was according to direction. Now this third, fourth, fifth are according to the number of variables. Simple correlation is a relation studied among 2 variables. When the relation is just studied between the 2 variables like price and quantity demanded, it is called as simple correlation. Then the partial correlation, when the 3 variables are taken and the relation is studied among the 2 variables, assuming the other is constant. Okay, let me tell you an example for this. The partial correlation means what? Whenever you study between the relation, you will take 3 variables. 3 variables will you take, and 1 variable among them will be constant. And here only the 2 variables will be studied. So for example, in a family, here mother is there and father is there and their child is there. Okay, so we are studying this. This is an example of partial correlation. Why? Because this variable, that variable child is being constant, and suppose anything issue happens, the relation is checked after that issue. The relation will be checked among this mother and father. So that will be called as partial correlation. Because why? There the child who is who is one of the variable, it's kept constant. So this was the partial correlation. I hope that example was jokes apart, but you will remember this. Then multiple correlation, when the relation is studied among 3 or more variables. Suppose what now the pre-monsoon has started. So whatever, how much rain is fallen, and what was the amount of thundering and lightning and rainfall. These are the 3 different variables. When you are trying to study, relate to find any association between this variable, here number of variables will be more, so it will be called as multiple correlation. Then we have linear and non-linear correlation. Linear correlation is what? When all the points on the scatter diagram tend to be near to the line, which looks like a straight line, the correlation is said to be linear. When all the points are in a straight line format, that will be called as linear correlation. Non-linear correlation means when all the points in the scatter diagram tend to be near a smooth curve. When the smooth curve will be there, it is called as non-linear correlation. This diagram will help you to understand that when this diagram here, on one line, all points are existing nearby to it, it will be called as linear, and here a curve will be there. It will be a non-linear correlation. Non-linear correlation is also known as curvilinear correlation. Now let's try to understand different methods of correlation. Different methods of correlation are there. Let's try to understand them. So in this methods of correlation, we have scatter diagram method, Karl Pearson methods. अरे ये कहाँ से आ गया? Okay, let it be. I am telling you, don't worry. So there will be 4 methods are generally used. That is scatter diagram, Karl Pearson coefficient of correlation, then Spearman rank correlation, and method of least square. These are the 4 methods studied to find out the correlation. Okay. So scatter diagram means, let's study the one by one. So the scatter diagram method is the simplest method to study the correlation between the two variables, wherein the values in each part of a variable is placed in a graph in the form of dots, thereby obtaining the many points as the number of observations. Okay, here what is when we plot a graph and where we try to study the correlation between the variables. So in the it is a graphical method. Scattered in this is the form of graphical method. Here we we plot points and try to study the correlation. So this was all about scatter diagram. Let's study the Spearman's rank correlation. The Spearman's rank correlation is based on ranks. Here we use the ordinal data set. Spearman's rank correlation measures the strength and direction of the association between the two ranked variables. Here first, what is done? The variables are arranged in order. They are ranked. Ranks are allotted to them, and then the association between the two variables is studied. Okay, it basically gives the measure of monotonicity between the relation among the two variables. That is, that how well the relationship between the two variables could be represented using the monotonic factor. Here a monotonic function is used to find the relationship or the association between the two variables. It is the formula for this Spearman's coefficient of correlation is P is equal to 1 minus 6 sigma di square whole divided by n in bracket n square minus 1 bracket close. Okay, so I am repeating this formula once again. P is equal to 1 minus 6 sigma d square whole divided by n bracket n square minus 1. So this was Spearman correlation. Here P represents the Spearman's rank correlation coefficient. Then Di is the difference between the two ranks of each correlation. N is the number of observation, and the Spearman correlation can take the value from -1 to +1. Okay, the value of either Karl Pearson or either Spearman. The range of this value is it will range from +1 to -1 only. Okay, a value of +1 measures a perfect association of ranks. That plus, if the value is positive, then we say that the perfect association of rank exists. Then if the value is 0, that there is no association between the ranks. Then if the value is -1, then there will be perfect negativity association between the rank. I hope this Spearman rank correlation is clear. Then we have the most important one, Karl Pearson's coefficient of correlation. Karl Pearson coefficient of correlation is extensively used a mathematical method in which the numerical representation is applied to measure the level of relationships between the linearity related variables. Here what we are trying to say, this method was given by Karl Pearson, so that's why the name is Karl Pearson coefficient of correlation. Here the coefficient of correlation is extensively used as a mathematical measure so that here what we are trying to how well the linearity variables are associated among themselves. The coefficient of correlation is represented by R. This is not 0, this is just R. Here it's typed by mistake, sorry. So the Karl Pearson coefficient is denoted by R. Then here yes, it is the widely used mathematical method where the numerical expression is calculate the degree and direction of the relationship between. Here the method is mathematical where we check the degree and direction of the relationships. Okay, then Pearson's method, popularly known as Pearsonian coefficient of correlation, is most extensively used in quantitative methods of practice. Where the methods practiced are quantitative in nature, in such methods we are used Pearson coefficient method, Pearson correlation coefficient method to understand the association between the variables. Okay, I hope you are understanding. The association of correlation is denoted by R. Same points were there, just the another name we get to know here. Now let's understand what are the properties of Pearson correlation. Here the properties are very important. That the first one is common, which we have studied in rank correlation, that the value will always exist between -1 and +1. Okay. Here the value will exist between -1 and +1. Then point 2 is what? If the relationship between X and Y is positive, then the R will be positive. This point is, remember, because there is a direct relationship. If the relationship is positive, then the value of correlation will be positive. Then if the relationship between X and Y is negative, the R will be negative. It's simply, very simple terms, it is expressing that if X and Y are positively correlated, the R will be positive. If they are negative correlated, it will be negative. Then fourth one is if there is no relationship between the X and Y, then it will be 0. There is no correlation, then the value will be 0. Point 5 says that the value of R will be +1 if the points X, Y lie on the straight line with positive slope. The X line, which we have said in case of linear correlation diagram, was there. This one. If the line is flowing in the positive, is moving in the positive direction, then the value of R will be positive. It's simply saying this. Then point 6 is what? The value of R will be +1 if the points of X, Y lie on the straight line with positive correlation. Oh, same point is repeated there here. Then one more important property is there, which I would like to tell you, that which is asked in exam many times. That this one. Here. This property is very much important, that correlation coefficient is independent of change in both change in origin and change of scale. So that was the point which I was telling you. Now let's see there are some Pearson Maharaj has given some assumptions related to his method. So what are these assumptions are there? Let's see. The measures are approximately normally distributed. These measures are normally distributed. Avoid using the highly skewed data. Here, skewed data will not be used, or data will be multiple modes will not be used. That should be approximate a bell-shaped curve. Data should be normally distributed. Point 2, that the variance of the two measures should be homogeneous or homoscedasticity. Check with the scatter plot. Here whether the variance of the two measures is similar or not, it can be checked with the scatter plot. Then point 3 is the sample represents the population. The sample should represent the population, then only the correlation between the variables will exist. If your sample doesn't represent your target population, then your correlation won't mean anything. Okay, if the population, because why? Statistics is what? It's the study on the it's all that your sample should represent your population. Then These are the three important assumptions which are related to Pearson's coefficient of correlation. First one is that normal distribution, then the variance of the two variables, two measures should be same, and the sample should represent the population. Now, this is the formula of coefficient of correlation. R is equal to n x summation xy minus summation x into summation y, then whole divided by under root n summation x square minus summation x square, then bracket close, and in the another bracket n summation y square minus summation y square square. Okay. So this is the coefficient correlation coefficient formula. Now here another thing is given, that when the deviation is taken from the actual means, here we have been given another formula, that Rxy is equal to summation xy divided by under root x square summation x square into summation y square. This is another formula. When the deviations are taken from the assumed mean, we use this formula. Here R is equal to what? N summation dx dy minus summation dx into dy whole divided by n summation dx square minus summation dx whole square multiplied by n summation dy square minus summation dy whole square. So this is the whole formula of our Pearson's correlation. Now here the 6 degrees of different types of correlation. This slide should be earlier, but here is now. Given the straight line, the points are on the straight line, there will be strong positive correlation. When the points are away from the straight line, it will be weak positive correlation. When the line is negatively sloped and the points are lying on it, there will be strong negative correlation. Then when the points are away from the on the negative sloped line, it will be weak negative correlation. When the points are lying nearby to that line, it will be moderate negative correlation, and when there is no relation between the points, there will be no correlation. These are the different degrees of the correlation. Now we have ended with the correlation. Now we will start the regression. Regression method was given by the person Francis Galton. Remember his name? Francis Galton was the person who coined the term regression. Okay. Regression is a technique used to determine the statistics relationship between the two or more variables and to make the prediction of one variable on the basis of another variable. Here regression is what? Regression, we talk about only two basic things, that is correlation, cause and effect relationships and prediction. Here value of one variable is predicted by using another variable. Okay. Then here two variables are used. Dependent variable is regressed or explained, and the independent regressor or predictor or the explanatory. Okay, explanatory variable. So this is the basic definition of regression. Remember this name, regression was given by Francis Galton. Now let's understand what's the importance of regression analysis. Regression analysis helps in three important ways. It helps, these are the 3 points which tells the importance of regression, that it provides the estimate of values of dependent variables from the values of independent variables. You can estimate the values of dependent variable from independent variable. Then it can be extended to 2 or more variables, which is known as multiple regression. If the values are extended greater than 2, then it will be termed as multiple regression. And point number 3, it shows the nature of relationship between the 2 or more variables. When it tells the relationship between 2 or more variables, it is called as the nature, what is the type of relationship, it can be understood by regression analysis. Now we have properties of regression coefficients. Regression coefficient also has properties. This statistics is completely full of properties and formula, nothing else except in this unit, because it is all about root learning. If you know the property accurately, you know the reason behind why it is happening, then you can easily find answer the question. Okay, all these things you have to remember, because by remembering this only you will be able to answer the question. It's a small brother of which one? Your higher education. There were only the years and names, author's name were there, but here different things are there. Let's take a 30-second break. Let me have water. Okay. So let's, we were discussing the properties of regression correlation. The coefficient of correlation is the geometric mean of the two regression coefficients. That is that R is equal to bxy into byx. Okay. Both the regression coefficients must have the same algebraic signs. The algebraic signs of the regression coefficient should be same. Okay. Then point 3 is the coefficient of correlation cannot have the same sign as that of the regression coefficient. The sign of the correlation coefficient and the regression coefficient should be different. Okay. Then point number 4. The both of the regression coefficient cannot be greater than unity. The value of both regression coefficient should not be more than 1. Okay. Then arithmetic mean of two regression coefficient is equal to or greater than the correlation. The arithmetic mean, if we calculate the arithmetic mean of two regression coefficient, it will be either equal or greater than the value of the correlation. Okay. Then here one formula is there, bxy plus byx divided by 2 is either equal to or greater than r. Okay. Then regression coefficient is independent of change of origin but not scale. Here one major difference arises that generally people get confused here, that the correlation is independent of both origin and scale. Neither the origin has any impact on the correlation nor the scale will have any impact. But in case of regression will be affected by origin but not scale. Okay, remember these points. Regression coefficient will be independent of origin, but the change in scale may affect it. Now let's understand the regression equations using the regression coefficient using actual values. Here the regression coefficient which we used to calculate in our MBA, MCOM. So regression equation y of y on x, y minus y bar is equal to b yx, x minus x bar, where the byx is equal to n summation xy minus n summation x into summation y whole divided by n summation x square minus summation x whole square. कितने बार रट्टा लगाया होगा अपने बीकॉम एमकॉम में इसको? The x minus x bar is equal to bxy y minus y bar, where the bxy is equal to n summation xy minus n summation x into summation xy whole divided by n summation y square minus summation y square. Sorry, minus summation y whole square. This simply seem whenever you see at this bxy, let me tell you, whenever you see this bxy na, and you have to find x on y, what will go in the denominator? The y will go on the denominator. Okay, and when you have to calculate y on x, here x will increase, here the x will come in the denominator. This is the best way to remember the regression equations. Then here y is equal to a plus bx, another, and how will you determine the value of b? B can be determined by n summation x into y minus in bracket summation x into summation y whole divided by n summation xy x square minus n summation x ka whole square. Okay. and A is calculated by A is equal to summation Y plus B into summation X whole divided by N, where the N is the number of observations or years, then X is equal to a year index decade, and Y is the population size for a given census years. So this formula is applied in another case. Mainly you have to remember these two regression equations. So here these equations are given in another form. In case of Y on X, it will be A plus BX. A is equal to Y minus Y bar. Same is there. There is nothing difference. Only the difference here is main difference. That is Y minus Y bar. To Y represent find the Y minus Y bar is equal to R multiplied by summation X into summation Y divided by not summation, sorry. Let me tell you again. Y minus Y bar is equal to R into summation Y whole divided by summation X. It's not summation Y, my mind is not working. It's sigma Y upon sigma X is there, okay? And X minus X bar. Sorry for the conclusion. Sometimes it happens when you are teaching from since long hours, it happens. Then regression equation. X on Y. X on Y, in case of X and Y, this will be A plus BY. X is equal to A plus BY. Then X minus X bar is equal to BXY minus BXY multiplied by Y minus Y bar square. Okay. Then X minus X bar is equal to R multiplied by summation X, summation sigma X whole divided by sigma Y multiplied by Y minus Y bar. Why this Francis Galton, this stupid fellow, has given so many formulas? These are very shameless people. They don't care that how our NET aspirants, how my students will remember all this formula. They have to remember the formula of coefficient of correlation, coefficient of regression, coefficient of all the measures of central tendency, dispersion, kurtosis. How much formula we will good? And in case other than this, finance has different relations, finance has different formula, accounting has different formula, either the economics has its own relation, another static portion is there in different units. Sometimes I think that our mind will get busted if we try to memorize all this formula. No need to worry. You just write it down, paste it on your wall where you are studying. Within the within a week, it will automatically, you will be able to recall from the identify from the option what is the correct formula of the regression equation. Either it is correlation coefficient, either it is dispersion, or either it is central tendency. Any type of formula you can easily identify. Just you need just took a piece of paper, just write all the formula of statistics and paste it on a wall. Or you can paste it on your study table also, where your paste it at such place that where your eyes are frequently catching that. By this, it will be set up in your subconscious mind. So this was all about the correlation coefficient, correlation and regression. I hope you might have enjoyed today's class. So thank you. Just hit the like button if you like the session and subscribe the channel. Thank you. Bye.